In this video, I want to discuss the best scalable architectural practice which you should be following as a full stack developer when you're building your front end and back end, and I'm going to justify why that is a great option. Let's go ahead and start. Now, this video is for people who are doing moderate to large size projects. It's not for people who are doing small size projects because the approach for that would be way much simpler. So only follow this video if you're trying to build a decent size, mid-size to large size project with the help of a scalable infrastructure on front end and back end, irrespective of the technologies which you're using at back end. Let's go. If you're new here, make sure you leave a like, subscribe to the channel and hit the bell icon. This is free of cost and helps the channel grow. Alright, so in order to understand this first, let us actually understand how a typical application might work. So I'm going to take example of Node and Express in this, but this is mostly like backend tech agnostic, right? You can pick up any other technology as well, PHP plus Laravel, anything which you want, it can work with that. So a standard application would look like following. You have a server, let's say this is an EC2 server, and you have a client browser. They send the request to you. This EC2 machine sends the files, let's say index.html in this case, and maybe this index.html makes an API request which goes to one of these routes in Express, which is like app.post or app.get or anything. And that is also handled by the same application. And the static assets, for example, are either served by Nginx here or maybe just by Express using express.static, right? Not app.static, express.static. So, and you can just do this and call it a day, right? But this is not fundamentally a good architecture for your front end and back end because you're doing a lot of work, including both front end and back end and database as well, potentially on a single machine. Let's understand a different sort of architecture and why that would have a few more benefits over this. So this is the architecture we also use on codedamn.com, which is an amazing site to become a full stack developer. At least for now, we are adding more learning paths, but this is the exact same architecture which we use in a production website you can see on codedamn.com. The what of this architecture is that we separate our front end and back end. Now, I won't be going into too much details on the back end front in terms of technology. We're going to just keep it a general backend related server. So it could be Fargate setup. For example, it could be a Lambda setup. It could be anything server or serverless. But the idea here is that this backend right here is most likely deployed as something like api.yourdomain.com, right? And your website, this real website, is actually accessible on yourdomain.com, right? So what we are doing is we are separating the API area of interacting with the database or any other computation which needs to be securely done on a different server. Now, the biggest reason for doing this is that now your front end does not need to be a server. It only needs to be a CDN. Why? Because your front end, in most of the cases, should be delivering static pages anyway, right? Either those are static pages or those are server-side generated pages or those are server-side rendered pages with some sort of caching in place, right? You don't necessarily want fully server-side render pages on every single refresh. This is usually computationally expensive and you have to do it only if your workflow really demands it for some reason. But in a lot of cases, you can get away with this. In a lot more, you can get away with this. Static side generation, not server-side generation, and server-side rendering plus caching. So assuming that you can get away with these two or these three at max, if it covers your 97% of the use case, that's a good enough reason to ditch a single server and use a global CDN as a front end kind of thing. For example, when you deploy on, let's say, CloudFront, or when you deploy on, let's say, Vercel, which also I think internally would use CloudFront, or you deploy on something like Cloudflare, not exactly on Cloudflare, but behind Cloudflare. But even with Cloudflare also has this concept of workers, which you can deploy. So when you deploy them on these 2, 3, 4, 5, 6 more cloud providers, which have this geolocation available on the world, then what happens is the moment somebody enters your domain, hit enter, the first result is immediately fetched by the user from a CDN, right? And then most likely this page is cached, so it's sort of like super fast. And even if it is not cached, if you're using static site generation, it gets rebuilt in the background where it can continue to communicate with your backend API, which might be sitting in a single availability zone if you're using, let's say, a Lambda thing. So that's fine. This communication happens async in the background. And once that is ready, your fast page is already there to deliver to the end user, right? Now, once that page is delivered from the CDN, anything dynamic on the page should still be in some sort of loading state where your client now will make a call to this backend server, right? So this backend server, which is API dot whatever it is, can now be reached and now be used to fetch and just insert the remaining placeholders. Because your website, if they're kind of dynamic, if you're using a dynamic dashboard, chances are you would have a lot of static parts there anyway, like the sidebar, the footer of the website, the header of the website. This area might be a little bit dynamic, but fetch all the data for this from your backend API via your client, but make sure you're able to serve the first byte really quickly with the help of CDNs. And that is only possible if you have a distributed CDN network like this, which is serving static files to your users, instead of like worrying a lot about what should be the structure to handle backend calls here as well. Because you could technically deploy a lot of backend related stuff here, but databases, I believe, is still one of those things where you might get a little caught up, because still most companies do prefer the standard MongoDB or MySQL or Postgres, which are usually, I mean, until you are using some new managed service from a cloud provider, which are usually restricted to a single availability zone or a single region, right? So you anyway have to have a VPC in that region where, let's say, your Lambda is running, which communicates with that, and you have to call that Lambda from pretty much everywhere across the world, right? This is at least what we follow right now on codedamn. If there is a way to use Lambda Edge somehow inside of a VPC and then call it and connect to a database. But then again, I don't think that might be possible because of the latency issue until your database itself is not globally distributed, which is like another topic altogether. But the thing here is what you have to realize that in the world, your front end could be localized, not really localized, your front end could be distributed. These all are your front end, right? And your back end, if it is in a single zone, this backend right here, which connects to the database as well, this should be not the bottleneck for loading your website, right? Because when somebody types your domain name, they would get the response directly from one of the CDNs, which is closer to them. Your pages can be generated statically on the backend, or you can do server-side rendering plus caching, which also happens on the backend. So it's again super fast. And anything which you need dynamic from the front end can anyway be called directly from the backend API, right? You can fetch that and do that. This architecture is much better than the one where you serve everything from a single location. Let's say if you have a standard droplet or an EC2 instance where you're serving the assets and basically regular files and everything, not only you are using CPU out there, no matter how small, for serving those files, but you're also hogging the network, you're also hogging a lot of resources otherwise be used for the backend processing and computation, right? So just ditch this single server based model, switch to a model where your front ends at least are served from all over the world using a CDN like CloudFront, Vercel, Cloudflare, things like these. And your backend, maybe if you want, it is localized to a specific location where inside the VPC, you also have access to your database. That's basically what we use at codedamn. And I believe this is something which you should use as well. I remember like one time I wrote this thing as one of the responses in a Twitter thread, and the CEO of Vercel also approved with me on this architecture. So I guess it should work. And he's like a great coder, just an FYI. Why WebSockets are fundamentally unscalable. Why do people keep on saying that, hey, WebSockets are not scalable, HTTP is more scalable? Why that is the case, let's understand in depth and how you can make WebSockets scalable with general market solutions. Let's go. Now, before actually getting into WebSockets, let's actually get into scale. What does scale actually means? So there are two kinds of scaling you will see on, infrastructures. The first one is horizontal scaling, and the second one is a vertical scaling. Now, vertical scaling is a type of scaling where you keep on adding hardware. That means you keep on increasing your RAM and your CPU, mainly because these are the only two bottlenecks which you will see on server, and CPU in some cases more. RAM in some other cases. But in vertical scaling, what you do is you're probably running a very strong single EC2 machine or whatever machine, and you just keep on pushing its hardware up and up. And there is a physical limit on how much you can push hardware, right? Beyond a certain point, it has diminishing returns. So this is not an optimal solution for web scale services. For example, you cannot probably run Amazon on a single server, right? Or Google on a single server, or any website which pretty much receives hundreds of thousands of hits per second on a single server, right? It's not viable. So then comes the horizontal scaling part. This is the interesting part, which allows you to distribute compute over a cluster of computers, right? So you cannot keep on adding hardware, but you can keep on adding new computers, right? Until the world runs out of silicon, but that's another problem. But this means that a collection of computers, small computers together, can pretty much compete against one very big machine. And the good part here is that you can also multiply these clusters, by 1,000 factor. So you pretty much have a lot of small computers, which in themselves alone are not so powerful, but when combined and when used together, they make a lot of scalable systems, right? So these are the two kinds of scalability aspects, the vertical and the horizontal. Now, when we say that WebSockets are not scalable, we mean WebSockets are not horizontally scalable, right? Obviously, they are vertically scalable. If you have a huge machine, you can pretty much add hardware to it, and your WebSockets, you will have more capacity to hold network connections and CPU and RAM and so on. But what we want is horizontal scalability. Why? Because, you can pretty much distribute a lot of compute over the whole cluster of nodes. And this is helpful because now this can receive any number of traffic, technically. All right, the second step in understanding why WebSockets are not scalable is actually take a look at how HTTP works. So HTTP, fundamentally, you have a client, then you have a server which connects for a brief time, sends a response, and that's it. You're done. The communication is over, right? If you want to do another request, your client sends another request, the server responds to another computer, to your another client request, and that's it, the connection ends. The important point here is that this server and this server are not the same. I mean, they could be, but they don't have to be. Why? Because your client, the information which your client sends, whatever the cookie or auth token or whatever, it's a complete state in itself. That means the protocol in itself can be stateless, right? This protocol, the underlying mechanism which carries this information is stateless because your server automatically can parse the state from the client. It doesn't need to be that same server again, because this could be a completely different server. Now, how does this benefit us? Take a look at the horizontal scaling. Let's say I have these 6 nodes running, as each of one of them as powerful as this one. And the first connection is taken by this, the second is this, and it's fine. I mean, it works, right? On vertical scaling, it might be a problem, but on horizontal scaling, you could pretty much assign a lot of these computers to different clients altogether, right? You're combining the compute power, and all you had to do was replicate your backend code on each of them, right? Which can be done with a click, right? It's not a manual process. Super easy. Now let's take a look at how a WebSocket connection works. So unlike HTTP, when you establish a WebSocket connection with a server, this connection actually stays alive all the time. This is a TCP connection. This is technically an HTTP connection upgraded to a WebSocket connection, but this connection right here, this pipe right here stays connected, right? This means, for example, if you want to take an analogy, you can have a client which connects a pipe for a split second to a server and then disconnects it and maybe connects it again, right? Then, disconnects it and then connects it again. This is the example of HTTP, right? Therefore, HTTP gives you enough time to swap this server with some other server, right? Or maybe add more servers to the bunch if there are a lot of requests coming in. WebSockets, on the other hand, if you're stuck with a server, that server is stuck. This pipe is not going down. If you remove this pipe, then the WebSocket connection would disconnect. And WebSocket is a stateful connection. That means once established, the client has to remember and the server also has to remember. Now, obviously for client, it is not a problem because at a given time, the user would not be having a lot of WebSockets connection open. But for server, a central server, which has a lot of clients to serve, this is a huge problem, right? And you can see all of these clients, which you see right here, they would be connected to a single server, or even if you have multiple server, that's also does not fix a lot of problems. Even if you have multiple servers, you cannot upscale and downscale on demand, right? You could upscale, but you cannot downscale. Why? Because you can see that you're stuck with some connections here, right? So you cannot just remove this instance, because that will remove all these connections as well. You could do that here because, you know, you can set this instance in a draining mode or something, and once all HTTP requests are done, you can remove it. You can do that here as well, but it's a lot slower because a WebSocket request might take an hour to complete, 30 minutes to complete, 10 minutes to complete. I don't know how much time a client stays active, but HTTP requests are generally in seconds, right? You click a button, something happens, the data transfer happens, and done. So that gives you this flexibility of swapping the servers, upscaling, downscaling, and so on, which you don't get in WebSocket connections. All right, so how do you make WebSockets connections scalable then? Well, you don't. As a developer, you don't have to worry about going into the infrastructure details and managing the hardware. I mean, there is no other way than having powerful systems, having a lot of powerful systems, and let them take the WebSocket connection and manage them, right? So that will be there. But in order to scale it, what you can do is you can separate the logic and the connection establishing area. What do I mean by that? On Amazon, for example, we'll take a look at Amazon because that's what I know. On Amazon, you have a service known as API Gateway. Now, this API Gateway, you can think of as a load balancer, which is huge and managed by Amazon. So you don't have to worry about this guy falling off. But what this does is that it can pretty much take in a lot of connections, more than you can imagine, right? A lot of WebSocket connections. And all of these WebSocket connections are connected here, you know, so the browser which is seeing, it is actually seeing a connected socket connection. But on the back end, in reality, what's happening is that you have multiple serverless functions called lambdas, and Amazon calls a lambda function on demand, right? And this lambda can call, you know, a special function on API Gateway to send a message. So it calls this function whenever, you know, this WebSocket sends a message. If it sends M, it's called M. Then it can respond at the same time or maybe sometime later. It can, you know, push into an SQS, which calls another lambda, which pretty much does the job, right? So what's the idea? Why does the system make it scalable? So it makes the system scalable because we have pretty much offloaded the hardest problem to Amazon, which is how you can just maintain a WebSocket connection. Now the client right here sees a pipe established to API Gateway, but this communication which is happening at the logic layer is just HTTP. So these are HTTP calls made to lambdas, right? And we know that HTTP is scalable, so Amazon just implements its own scalability of HTTP here, and with lambdas it's easy. So API Gateway is, again, because it is huge, it comes with certain limits. For example, it cannot be idle for 10 minutes. That means your WebSocket has to send some message at least once every 10 minutes. I think that's the lowest payload. I mean, the highest amount of time you can set. And the second constraint which I remember is the WebSocket connection can only stay alive at max for 10 hours. I think 4 hours, not 10 hours. Correct me if I'm wrong in the comments. For 4 hours, you can keep this socket alive. This is a hard limit. That means after this, Amazon would forcefully drop this connection, right? Which is fair, I mean, because they also want to replace the hardware, right? Because this pipe is connected to some server, and let's say, you know, you just keep this connected for 10 days, right? I mean, that's bad for Amazon because they have to keep a server alive. Maybe it's just your connection and this has a degrading performance or something or whatever. But these servers which Amazon owns, they have obviously certain limitations compared to just a full-blown WebSocket server, but this is highly scalable, right? So you trade in a few things, which is a true WebSocket nature in your code for HTTP based calls, but you get a lot of scalability. And by scalability, again, I'm referring to tens of thousands of concurrent connections together, right? You know, a simple Node.js program, again, this depends on your requirements, but a simple Node.js program can easily handle, like, if I had to give a rough estimate, 500 to 10K maybe, depends on your workload, if your WebSocket connections are idle or not, and so on. But yeah, I mean, if you're developing a very small application which would not be used by more than a few hundred people, then you don't have to worry about the scalability aspect while implementing, but it's always nice to know how to do that when you are there, right? And all of these are managed services, API Gateway, lambdas, and you will find equivalents for them in other cloud services as well, for Google Cloud and Azure and stuff like that. But This is how it works, at least in Amazon. And again, some companies actually do this layer of work by themselves as well because of the API gateway limitations. But yeah, I mean, this is probably out of scope of this video because I don't know how to set up an API gateway like infrastructure, right? You would only need to ask Amazon or some high traffic cloud provider on how to implement this. But yeah, for us, for developers, that's what we use, at least for now. Hey everyone, welcome back. And in this video, I'll be sharing how you can create a highly scalable video delivery infrastructure and pretty much show you what we do at codedamn. If you have seen any codedamn course, you know we have videos embedded and interactive exercises embedded as well. But if you closely look at the videos are not embedded from YouTube, any other third-party player, for example, but they are custom optimized and delivered as well. So in this video, my motive is to not only just how to deliver, but how to create this full pipeline. And this will involve a lot of infrastructure, architecture, and I know a lot of you have been asking me this for a very, very long time. So let's just go ahead and see how we can create one. Also, if you're new here, make sure you like and subscribe to the channel. I'll be doing more such videos, live streams and things here. And yeah, I mean, if you don't want to miss it, make sure you hit the bell icon, subscribe to the channel, and also like the video. It helps feed the algorithm. Okay, so video processing, where do we even begin? The first thing you have to realize is that your video, whatever you're trying to process and put in front of the user, it has to be optimized in a certain format. The reason for this is web currently does not support every single video, right? And most of your videos, for example, this video which I'm shooting in 4K 60 FPS is 4 GB for 10 minutes, right? And this is exactly not what you want or what you're watching on YouTube, right? So YouTube is also processing this video in some format. That's why they are able to deliver it to you so fast. Your internet connection, I hope, is not something which can afford 4 GB per 10 minutes. I mean, even if it could, it's not worth it, right? So what you want to do, first thing is that you take up the video which the person has. Let's say this is an MP4 video. It could be any single format. And the first thing is to upload it to cloud, right? So the very first thing you would want to do is create a signed S3 URL. Now, what is a signed S3 URL? AWS is huge, right? They have a lot of capacity for compute, storage, and everything. So what AWS allows you to do is it says that, okay, we have our S3 bucket here, right? It is a bucket and it can virtually store a lot of data. I won't say unlimited because nothing is unlimited, but it can store a lot of data. You cannot even imagine. So what you do is you ask S3 that, hey, give me an address, a signed URL where whatever I put anything, it just uploads, right? So the compute is S3, the infrastructure is of S3, and you don't have to worry about what's the file size here. It could very well be 1 terabyte. It could be very well 1 megabyte, right? If you route it through your own server, then you have to make sure that your server is able to handle file of that size, or you're streaming it properly to S3 then, but so on. But what you do is you create a signed URL from S3, which is AWS, and then you upload it to an S3 bucket. Uploaded to S3 bucket. This is where the fun begins because now you have this on the cloud, right? And I'm gonna stick with S3 and AWS infrastructure because that's how we have deployed our pipeline at codedamn. But you can pretty much choose any cloud provider. I believe most of them will provide some sort of functionality like this. Now, what S3 allows you to do is it allows you to link a bucket with a service called SQS, which is a queuing service from AWS, which stands for Simple Queuing Service. So this means, let's say if I have a bucket which stores file number 1, something, something, file number 2, something, something, so on. What it can do is on the next upload, whatever it is, right? It could be a video file, it could be anything. This S3 bucket can add a message to this queuing service. And this SQS is just a simple queue, right? Where you read the message and you can push the message as well. You can read and push. So like a queue works, you have, and queue is a data structure. Data structures are super important, but not for competitive coding only. I have created a video on competitive coding versus software, so maybe you want to watch that as well. But anyway, what happens here is that you add certain elements and you can take them out from the front. This is what SQS does. But the only good thing, or the only major reason you should use SQS over implementing your own queue is that this is highly scalable, right? This is highly scalable for receiving tons of messages or tons of inputs every single second as well, which your data structure would struggle to do. But anyway, what you want to do is every single time an item is added to this S3 bucket, you want to push a message to this SQS. And this is inbuilt behavior with AWS, right? AWS provides this, that whenever a file is uploaded here, a message gets added here, right? So this could be a message, right? This could be a message. This could be a message. Let's say I uploaded 3 videos together. So this queue has 3 messages. And that's it. That's where the job for S3 ends, right? Now, AWS also provides you a service known as CloudWatch. And what this CloudWatch can do is you can set an alarm inside CloudWatch to do certain action whenever the queue size is greater than 0. So you can create an alarm in AWS that whenever the queue size is greater than 0, I want to do something, right? Or if the queue size is equal to 0, then also I want to do something, right? These are the 2 actions which we need in CloudWatch. And I'm going to tell you why we need these 2 actions. This first action right here is responsible for launching an EC2 machine. So that means whenever the queue size is greater than 0, what we want to do is we want to launch an EC2 server. Now this EC2 server could be a powerful server as well, it could be a mini server, whatever this is. But this server has 2 jobs. The first job is to actually read a message from this queue, right? So this queue is there. It wants to read a message from this queue. And I told you, like, we uploaded 3 files, so 3, 2, 1, for example. What this EC2 server did is that it just read the first message. So it got this first message right here and it started processing this video file, right? And what happened was this message actually contained the path to the S3 bucket, right? So this EC2 machine knows where it needs to go and download that file, that particular file. So it processes it. EC2 just launches FFmpeg, for example. We use FFmpeg for processing. You use FFmpeg and convert this into 3-4 formats, whatever you want. For example, 1080, 720, 360. If you want adaptive streaming and HLS and stuff like that, all of that can happen right here inside this EC2, right? Because it has got access to the main file via S3, which you uploaded here, right? So the moment you do that, this EC2 now has access to this MP4 file which you uploaded, right? In a highly scalable way. There is no component here which could break down or collapse under load, right? Given that AWS in itself isn't down. And of course, this does not has redundancy built in. So if, for example, SQS is down, you might have a loss of message and something like that. But those things we are not discussing. We are just discussing, let's say if AWS is up and we don't have any redundant systems, what is the minimal setup which you need? So once you have SQS delivered this message to EC2, for example, and I'm assuming you are choosing a sufficiently EC2 size so that this does not bottleneck, or you maybe can reject just files over 10 GB or 20 GB, whatever. You process it with a tool like FFmpeg and create certain resolutions. The next thing is you upload them back to a production S3 bucket, right? So for example, this is your production S3 bucket. And because you have processed a single video right here, you can just upload them back here and update any database entries. For example, in our case, we link that video to a particular video in the course, right? So you can update any database entry. Once you do that, and you also have your video files processed in the production S3 bucket. Now this S3 bucket can sit behind CloudFront, right? CloudFront is a CDN service from Amazon. So all the traffic which receives, for example, for that video needs to go through CloudFront, where you can create these signed URLs and cache this stuff right here on the CloudFront for faster speeds, right? And then CloudFront can access it in a secure way from S3. So that is pretty much all it takes. The important part here is that one EC2, or depending on how you want to architecture it, in our case, what we have done is one EC2 gets launched every time the queue is greater than 0. And what do we mean by that? That means every single time this is running like once per minute or once per 5 minutes. And every single time queue is greater than 0, one EC2 gets launched. This EC2 takes up one message from the queue, tries to process it. If it is successful, then this message is permanently removed. If this fails or something happens, then this message goes back and it's retried again after some time, right? It goes back at the end of the queue. If this keeps on failing, then we have another concept of dead letter queue, DLQ, which is something different, which just stores all the failed videos in case somebody uploaded a text file, for example. Then of course that will fail multiple times because it cannot be processed by FFmpeg. But yeah, once you do that, this second EC2 is able to pass the second file right here. The third file is passed by another EC2 and so on. So you see what we have done essentially is distributed the compute part inside multiple EC2s and distributed the storage part, and not exactly distributed, but offloaded the storage part to S3, because S3 we know is solid, right? S3 has SLA of 999, I think 5 nines, right? And this is like a solid guarantee that your files would be available for this much time. I'm not sure if this is the exact number, but something like that. Similarly, the compute part EC2s, a single EC2 is handling a single file. It can take 5-10 minutes and be done with it and deploy it to S3. That is fine. Right here, we use the auto scaling group ASG, which creates all these multiple EC2s, right? So the CloudWatch alarm is bounded with this auto scaling group, which increases the amount of EC2 instances. And whenever these EC2 instances launched, this is launched from a template which knows what it needs to do, right? A snapshot, a template, whatever you want to call it, thanks to this ASG group. And once that happens, it reads it from SQS, processes it, deploys it to production S3 bucket, which then is readily available for serving to end users, right? So now if you go to any codedamn course page, for example, you will see that you have an option to switch between 720, 1080, 360, 480 qualities, right? So that is because we have formatted it into 4 formats and delivering it via S3, right? All right, so we have discussed Q greater than 0. For Q equal to 0, what happens is that this is 0, like I said, if there is truly no video to process, and this is also 0 if all of the EC2s, for example, we have 2 EC2s which are processing 2 videos, right? Then also the queue size is 0, right? Because there is no message in the queue which needs to be processed, right? So this is where we are hitting this condition. And at this condition, what we want to do is we want to attempt to delete these instances, because queue size is 0. Then the auto scaling group, this ASG, and my handwriting is really bad, but this auto scaling group right here, it should try to downscale the EC2s, the pool of EC2s it owns, right? This ASG owns it, and therefore it tries to downscale it. Downscaling, I mean, it tries to destroy these instances which are present. But there is another thing which we can do here, is we can protect this EC2 instance from being destroyed by setting a deletion lock, right? So EC2 instances can set a lock like this, where auto scaling group will not be able to destroy it. And when we will do it just before the processing starts, right? So this is the processing phase, this is the lock, and once the processing phase is over, then you just unlock the EC2 instance, right? So the moment the video is processed, it's done, then you unlock it, and ASG sees that, hey, there are no queue items, I want to downscale. It sees that the EC2 instance is unlocked, it destroys it, and you get a scalable architecture which upscales and downscales depending on what is your need at the time. So this was a very high level overview of the architecture and how it works. Obviously, this is more complicated in the code and how you place all the architecture bits and bytes, but this is fundamentally how and what powers codedamn even today in terms of video processing, and maybe a lot of other sites as well, because this is an approach which is scalable. If you want to make any changes, you just need to make some changes in the EC2 scaling part. And the best part is this whole process is very, very cheap. And I'll just quickly give you an idea why. Because you will see that right here, uploading to S3 has a cost of $0, right? Because S3 has ingress bandwidth as free. That means if you're uploading something to S3, uploading to AWS Cloud, AWS does not charge you for that. Then SQS, sure, has some fees, but it's relatively lower. I mean, it's not that much, right? Then let's see, CloudWatch Alarm also has some fees, but it's again relatively lower. These EC2 instances which you create need not to be reserved instances, right? These instances could be spot instances. So what a spot instance is? Spot instance is additional compute capacity available to AWS, which they will sell at a 50 to 80% lower price, right? So if you pay, for example, I don't know, like 10 cents an hour for an EC2 instance, you can very well get it for like 2 cents or 3 cents an hour, right? So that's possible. EC2 has the spot instance concept, but the only drawback for this is AWS can terminate this anytime, giving you a 2-minute notice. But for this task, it does not really matter. Let's say this EC2 instance gets terminated, then this message which it took will get restored in the queue, right? And would be picked up by another EC2 instance later. So that's completely fine. So you get a very low cost here of processing on EC2 because you can have big machines processing, but at a very relatively smaller cost. Then again, this machine, when this downloads files to EC2 from S3, that is also free because this is running inside AWS infrastructure, right? So this part can be made free if you have EC2, then basically the infrastructure in a similar region. Finally, when you upload it from EC2 to production S3, that is also free because like I said, it's the charge for uploading it to basically S3 is 0. And the only price which you pay realistically, which you should consider actually, is when people start hitting your video, right? The data transfer cost, because this is where Amazon makes real money because their data charge is pretty high, but rest of the stuff is pretty good, right? So yeah, I mean, this model is, I think I ran some numbers, and if you consider, for example, Amazon's Media Kit, which is a all-in baked-in solution for this is probably, I don't exactly remember what the number was, but it was close. It was definitely above 10 times, even 20 times cheaper, right? So this model, when you deploy it yourself, it's 20 times cheaper, but again, it increases the difficulty of your architecture. But if you're like me, back in the days, if you're simply free and want to experiment with this would actually make a great system architecture project on your resume if you would like to have a job like that, for example, creating a full infrastructure, full architecture design from scratch. Proxies and reverse proxies, and especially even with reverse proxies, we'll just go a little bit into Nginx because I have worked a lot with Nginx and it is a fantastic open source free reverse proxy software available. So let's see how these work and what these exactly are. Also, if you're new here, make sure you leave a like, subscribe to the channel and hit the bell icon in order to receive free daily updates on programming on codedamn. Okay, let's say you created your own family website. Let's say this is family.com or whatever, and then / I have my name, Mehul, right? Let's assume this page should be rendered by a Node.js app, right? Because Node.js is my favorite programming language. Let's say the second member, we have M2, for example, likes Vue.js a lot, right? And this is just a static website, for example. This is obviously a server-side rendered thing because we are using Node.js with, let's say, some EJS as a system. And then /member3 likes to have PHP, right, as their homepage. Now we want to create this system. How would you possibly create something like this? Just think about this for a minute. Now, if you have watched the codedamn HTTP fundamentals course, which is a free course on codedamn.com, you know a few things about how domain names work. So you see this domain right here could ideally at a given time only resolve to one IP address which your browser would connect to, right? So this would be a single IP address. And for the sake of simplicity, let's just assume for now that you're hosting this on EC2 or some standard Linux virtual machine, right? Now, the problem is that whenever your browser tries to connect to server, the first step in the connection part is that it locates that server with the help of this IP address which you specify, and does not use this path information or anything, or even port numbers if you specify in this communication, in the initial communication, right? This path and everything goes in the HTTP body when the communication is happening. So that means the option of having multiple servers is eliminated, right? At least right now. So in terms of, just keeping the thing simple, if you have a simple IP EC2 instance, you pretty much cannot point it to different servers on just different path names, right? They have to point on a single IP address at a given point. Okay, so this is where the things get interesting. What we actually wanted to do is we wanted to say that, hey, my client, I want, if you're on /Mehul, then you want to have this Node.js, which might be another server like you were thinking. This could be another server for, let's say, M2, and this could be another server for, let's say, M3, right? But we just showed that this architecture is not possible. So what we do instead of this is that we write a special program on the server itself which does this handling, and we put client one layer behind, right? So your server right here now determines what path you are coming in this specific case, right? Whether it's Mehul, whether it's M2, whether it's M3, and the client is just connecting to a regular server, right? So this might as well be EC2. Now this is interesting because these can be separate EC2s, and this software which does this right here is called as a reverse proxy. It's as simple as that. Reverse proxy is just a piece of software which does this mapping in some way, which does this direction of control in some way. Now this is not specific to just path, it could be pretty much any criteria from TCP, that is layer 4. I think layer 4 is the lowest you could go in Nginx, to all the way to HTTP, which is your application layer at layer 7, right? So you can do this with Nginx. You can do this with HA proxy as well. These are the two proxies I have used personally, and I mean, I do recommend Nginx, but HA proxy is also good for some use cases. But yeah, I mean, for Nginx, you can pretty much do this redirection on the applications, whether it's Node.js, whether it's PHP, whether it's Vue, whatever, with the help of these path names. Or you can do them on the basis of port numbers as well, right? So for example, you can have a port number 3333 for this, then 3334, and so on. Or you can also do it for subdomains. I mean, as long as a bunch of paths, a different set of URLs go to the same host which has this Nginx proxy running, you can perform this redirection, right? Now the point is that how does this reverse proxy system actually works? Let's look into that. So in this specific case which we are discussing, what will happen is that your client actually hits Nginx at the very first place. And the reason it hits Nginx and not your Node.js or any other process is because Nginx as a server is listening on port 80 or port 443, which is the standard port for HTTP or HTTPS. So when that happens, now Nginx is in control, right? And the job for Nginx is not to do any processing, not to compute this and that, which your application does, but it's just simply redirecting stuff, at least in most of the cases. So what it will do is that you can specify, let's say you have a Node.js server here, which listens on port 1234, right? Then you have a PHP server, which is listening on 1235. Then you have a Vue.js server, which is of course static. So these are just static files, but there's a static server running with the help of Express or whatever. And this is on 1236, right? Let's say. So you see, these applications are listening on ports which are not accessible via internet, right? So these ports are not accessible via internet. That means ideally, if they were accessible, you could just write port number 1234 and bypass Nginx, but that's bad for security as well as for getting this infrastructure ready. So what we do in fact instead is that if I'm writing /Mehul here, Nginx allows me to write a rule that, hey, if the location is in fact Mehul, I want the proxy to pass at this port number. So I'll say proxy pass localhost 1234, right? So the reason I'm writing localhost here is because I'm assuming that Node and Vue.js and PHP are running on the same host as this Nginx is running. But this need not to be the case, right? It could very well be in the same intranet or, in the same subnet. So that way, this redirection would still work, right? You would have to specify a different DNS name or a hard-coded IP address, but this would still work. Now, why is this thing important? Well, you can think of Nginx as the ultimate middleware to your application, where you can perform all sorts of things in a very, very, very performant way, because Nginx is written in C or C++, I don't know, but you can see it's not your Node.js thing, right? So C and C++ are actually very, 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 very performant languages. I mean, closest to assembly. So you can do some real performance, good damage if you're writing your softwares in C and C++. So Nginx is performant. It is feature rich. That means you can do rate limiting, you can do WebSockets connections, you can do, there are so many options to do. You can do load balancing, you can do a lot of stuff with Nginx, right? So, but the core fundamental of reverse proxies is the following, that it just sits as a front layer in most of the cases and then distributes the traffic to different applications or sometimes maybe the same application running differently just to act as a load balancer, right? So for example, a standard use case of Node.js app would be to have an Nginx process, and then let's say 4 node apps, right? And when would you do that? You would do this on a 4-core system. Why? Because a Node.js is single-threaded app. Therefore, you're using all the 4 cores of your server now with the help of Nginx load balancing, kind of, right? So you can perform the same load balancing with Nginx, HA proxy, pretty much any other reverse proxy application as well. But this is how, and this is why you need a reverse proxy in your life, because now all the authentication, all the rate limiting, all that stuff could be in a single place. And most importantly, the TLS termination as well, because this is also computationally a bit expensive. I won't say much, because now, I mean, it's basically, the standard stuff, but TLS termination is much faster in Nginx compared to Node.js. TLS termination is just converting your HTTPS traffic to HTTP. And why you need that? Because your applications need to read plain text information coming, right? They don't need to read the garbage. But yep, that's pretty much it. I think we covered most of the stuff which needs to be known as a backend developer if you're just starting with reverse proxies. Now, this video is for people who want to go one step ahead and not just build projects, but also deploy them on live URLs. We will also see how we can set up a custom domain behind Nginx and have an HTTPS certificate and HTTPS lock, green lock available there as well. So I'm excited to start this video, and hopefully you are too. Let's go. So in this video, we'll be using DigitalOcean as our cloud provider. Why? There is no specific reason. I could have used AWS, but I do feel like AWS is a little bit more complicated for new developers who are starting off with cloud for the first time. So DigitalOcean is easy to get your toes, dipped into the water of clouds and stuff, and then move to AWS if you're doing any serious stuff. I have a link in description, which is a $25 referral link. So you get $25 when you sign up using that link for free. So that can act as something where you can just experiment, right? So check out that link. You'll get $25. You can use that. Pretty much everything we cover in this video can take you a long way in that. So I already do have a DigitalOcean account. You might want to create one using the link in the description. But once you create, you're going to be presented with a page like this. Now, in order to deploy our application first, you can see that we have a server folder right here with us. This means we need to spin up a Node.js server. And for that, we need a computer which is running 24/7, 365 and can respond to people's requests, right? So the very first thing, just like you create a server on your local, but you can just move away or, shut down your laptop, we create a server on the cloud, but this server does not shut down, right? These are servers running in server farms and data centers across the world, and they can pretty much serve your website even when you're sleeping, right? So I'm going to go ahead and go to create a droplet right here, which is going to act as a computer, right? And you can start with regular Intel SSD, $5 per month. That's fine. You can choose a premium processor as well if you want, but this is like the cheapest one which you can get for now. Just pick up any city. If you don't have any preference, the servers what I have seen in my personal opinion in US have a slightly better internet speed. I don't know, like I haven't really done a lot of benchmarking, but definitely faster than Bangalore. So if you choose a New York or San Francisco, you get faster connections there on that server. So right here, I'm going to go ahead and let's say not select any one of them. That's fine. You can create a password for now. For the sake of simplicity, maybe we can get into SSH key generation and all the practices which you should follow in terms of hardening your server sometime later. But this video is about setting up the code on a production server, right? So I'm just going to keep my password abc@12345. So I have created a password which I have just written right here, and I'll obviously destroy this instance before this video goes live. But just for the sake of simplicity, there we go. YouTube video would be the title, and you can just give it some tags. My instance, that doesn't really matter, but there you go, and create a droplet. So what this droplet is gonna do is it's gonna create this YouTube video, $5 per month, 1 virtual CPU, 1 gigabyte, 25 GB droplet, and it gives you this IPv4 address, right? If you copy this address and go right here in your terminal, what you're gonna see is that you can SSH into this droplet. And how do you SSH into this directly is you say root @ you paste this IP address, and if you want a little bit more information you can pass a verbosity flag. Otherwise this is also fine. You can just do an SSH root @ the IP address, and it refuses because it's not completely booted, so give it a few seconds to boot completely. And once this is done, once the computer, the operating system, everything is up, you can SSH it directly. It will just ask you for a confirmation that do you trust the fingerprint of this. Again, something we'll discuss maybe sometime later, because this lies more on the advanced side of things, but you should ideally just, you know, pass in yes here. And it says that it has permission denied. Let's try it one more time, because it said permission denied when it should have asked for the key for the password, and there we go. So the password right here is this for now. Ideally you should be using an SSH key, but yeah, I don't remember if I have the correct SSH keys for DigitalOcean set up on my system. But anyway, right now you see that I am inside this root @ YouTube video instance, which is actually this computer right here running on this port. Right now, by default, if you open up this instance, this droplet, and go to the networking section in DigitalOcean, you have no firewall applied by default. What does that mean? This means that all the incoming traffic and all the outgoing traffic is allowed on this droplet, right? Which is a good setting for beginners, but not so good if you are doing anything advanced. So we will take a look at how you can set up the firewall later. But for now, the first thing we need to do is set up our project itself, right? So the first thing I'm going to do is I'm going to do some basic installation. I'm going to go ahead and clone this repository. First of all, I'm going to do a git clone of this repository, which is the full MERN stack video. And right here, right away, you can see that we have the client server, just like we have inside our VS Code, right? But it doesn't really matter in terms of VS Code. But you see this server right here does not even have Node.js installed so far. So what we need to do, first of all, is apt-get update and apt-get install npm. I mean, there are a couple of ways you can install Node. I have remembered one way, which is kind of hacky, but it works. So you install npm from apt-get, which installs an older version. Then with npm you install n, which is the node version manager, and with n you upgrade to the latest node, right? It works. There might be cleaner ways to do that, but that's something at least I can do without actually Googling or looking up on internet on how to do that. All right, so once this is installed, what you will be able to see is that you have npm installed, but so they have updated it. Earlier it used to be version 3 or something, but it's still older. So what you need to do next is to npm install global n, which is the node version manager right here. And then you just say n latest, as far as I remember. N latest. There you go. So it's just gonna install node 16, which is the latest node for now. Once you do that, you can just respawn a shell or just exit and SSH again. Basically one and the same thing. But what this would do is just set up the environment correctly. Reboot the environment variables and stuff. So now when you do node v and npm v, you're going to see that you are on latest versions. But what you're going to see for this project, at least, we used yarn and not npm. So we're going to have to install yarn, and I'm going to do npm install globally yarn, and we want the first version of yarn because yarn 2 is a bit of a problem because it does not follow the same module system and the way modules work. But anyway, once you do that, you can see we are inside the client folder. I can just do yarn or yarn install. Pretty much everything would work. And the second thing we need to do is have to go into the server folder. Now, the way this would work, ideally, is we would not have two folders, but rather just the server folder being served, which serves this yarn folder to us, right? Which serves this front-end folder to us. If we take a look inside our application right now, what you're gonna see is we don't serve anything at all when we hit the get route. So what we have to do here instead is we need to add a condition, something like app.get star, and right here we need to just send the index.html from build folder, right? This is something which we need to do right now. So once we do that, you're gonna see that right here we have the node modules installed. The next thing I'm going to do is just going to say inside the package.json, we have inside of the client, we have a command called build, React scripts build, which creates a build version of the project. So when you run React, this yarn build command, it creates an optimized production build, which is minified JavaScript, which is just static build and static stuff, and it just puts it into a build folder. Ideally, all of these steps would go into a continuous integration pipeline like GitHub Actions, but we'll start slowly. We'll start it on the server side and then eventually shift it to a CI/CD complete pipeline where you don't have to worry about anything at all, right? So let it build. Meanwhile, what we need to do is we also need to configure the server repository. Server repository is pretty much simple because we just need this part of the thing. And the second thing which we need is just a way to start and restart the server using PM2. All right, so right now inside the build folder, you can see we have all we need in terms of serving a static location of the website. So for now, what I'm going to do is I'm going to move this build folder into the server folder and call it as static, right? That's it. Now let's go into the server folder, which we have, and do a yarn install again, because this is something which all the modules which the server side would need, and it's relatively fast because there's not a lot server needs. Okay, the next thing is we need an editor, which is always handy. Nano is installed by default, but yeah, you could install any other editor as well if you want. But this editor would allow us to do searching and replacing. So the first thing we need to do is let's put this on port 80. We can shift it to port 443 again, slowly and steadily, step by step. But the first thing we are trying to do is just get the things up and running. So this is one thing. The second thing we need to do is also serve the statics, like I said. So one way to serve that would be using the middleware by passing it through Express. All right, in order to do that, we'll just say app.use express.static, and the directory we have is statics, I hope, and that's it. Once we have that, we can pretty much just see, we have static here, not static. So let's just quickly rename that by telling it it's static, and there we go. In terms of setup, this is more or less all we need to execute the programming language. So now if I just do a node index.js, all we will get is a MongoDB error, which is like we expect, right? And the good thing about Node is that you would not expect this to fail if this was before Node 14 or 15, I think. But from Node 16 onwards, the promises actually crash the Node process, which is a good thing, right? Because this means we cannot start our application if the database is down or, if some promise is failing. Good thing. So the next thing is we need to install MongoDB. So for MongoDB, we have two options. The first option is I can go ahead and install this on the main server itself, which is fine, which would work. But a better option is if you have the ability to use a managed database, then mostly always go for that if money is not a constraint. So you can go to this databases section on DigitalOcean, and you will see that DigitalOcean actually provides you a managed version of MongoDB 4.4, which is awesome because it costs you a bit more. You would see that it's $15 a month for 1 GB RAM, 1 VP virtual CPU, and 15 gigabytes of hard disk, whereas a simple raw compute instance is $5 a month for the same specs. But the fact is that this is managed. That means this cluster or this instance would be managed by DigitalOcean. You don't have to worry about the data loss, or this going down, or the disk just filling up completely and then crashing, and even backups in some case. I don't know if DigitalOcean provides that out of the box, but managed services are mostly easy for everyone basically, because you just offload a part of responsibility of managing the infrastructure to somebody else, to a cloud, right? So in this case, I'm going to choose the San Francisco VPC. Why? Couple of reasons. The first one is obviously this will be closer because this is the same instance. And the second one, that this actually can lie in the same VPC, right? We have a YouTube video in SFO3 region. That means you can communicate the MongoDB instance over a private IP, which is of course faster because you don't have to route your traffic over to internet. So we can say this is like YouTube test DB, something like this, and the project should be my own. And there we go. Just create a database clusters. You can just keep a minimal database as well. It's fine. And all this would do is just give you a string of URL where you can connect your database to. So you can see it's setting up your database. Meanwhile it's doing that, we can do a little bit of other stuff which we need to do, which the first thing which comes to mind is actually setting up a PM2 instance. Now what a PM2 is? PM2 is a process manager for Node, which basically just keeps your Node.js server up and running if you are using it in a server full environment like this. So what it just needs to do is just need to install PM2 globally, and then you just need to say PM2 start whatever the name of your thing is, right? Just like we do with NodeMon, PM2 start does the same thing, but it starts it in a production way, which means that it will monitor your process for crashes and freezing, and if you want to restart it or reload it gracefully, you can do that with PM2. So all of that good stuff is available, and you also have, you know, nice analytics, because that's the bare minimum things these tools give you. But yep, let's wait for this database to provision. Meanwhile, what we can also do is, while we are at it, we can install Nginx in the server. Why? Because that will be needed when we convert our website to HTTPS, right? So ideally, we never really want our application to listen, the code of the application to listen on any port which is less than 1000, because all of those ports are reserved, right? That means you need a sudo permission to open a network connection on those ports. So what you ideally want is a reverse proxy like Nginx sitting in front of all the connections, and then it being proxying all of that stuff to your Node.js application. Why that is helpful? That is helpful because Nginx can manage a few things much more efficiently than Node. For example, static file serving is one, TLS termination is another, and a bunch of rate limiting, for example, that is much faster. Pretty much anything you can do in Nginx would be faster than Node because that's written in C++. So all you need to do is say apt install, and probably looks like my S key is broken on Mac. But if you do apt install Nginx, that is all it's gonna take to install and set up and run Nginx on, and run as well. I mean, I'm pretty sure it also runs it, but we can just verify it once by pinging localhost 80, and you can see that we do get the Nginx response. And by the way, instead of doing this the geek way with curl, you could have also visited this website which we have, right? The IP address directly. So you can just say copy and paste it right here, and you would see Nginx page being up and ready here. Now the next thing we need to do is obviously go into etc Nginx and modify the configuration a little. And as far as I can remember, this is somewhere in sites available. And if you go to default, all you have to do is add a location block right here, right? So instead of root and stuff and doing all this stuff, you can just comment this out, and you have to say for all the locations, all you want to do is proxy pass on localhost 1337. Again, not the best and the solid configuration which you would want, but this would work. And once you do that, all you need to do is just say sudo service restart Nginx, sudo service Nginx restart. It has been some time I use some server full environment. I'm usually using serverless. But anyway, once you do that, what you will see now is that Nginx, this page would stop loading, right? It says 502 bad gateway. And the reason for that is nothing is really listening on port number 1337. But we know that our application would be, once we, just make it proper. And right here, meanwhile we were doing this, our database is ready. So let's just make those couple of changes and see how that looks like. So let's get started. Let's add a trusted resource for YouTube video, and because we are in a VPC, so that will work just fine. We have the username, we have the password, we have the host name, and so on. So let's show the password. Let's make these changes right away. So I'm gonna go into the server folder, nano the index.js file, and let's comment this out, and let's say mongoose.connect mongodb. We have the username, the rate password with the host name, and the database is admin, right? And you can just add a new protocol, which is the plus srv thing. So MongoDB plus srv. That's fine. Once you do that, save this, and also, yep, we also need to remove the port number from 80 to 1337 because that's where we are redirecting our traffic for Nginx. The moment we do that and hit node index.js, it should hopefully work. And I did some problem here in terms of writing this. This should be actually separated by a colon, and this is GQ, and then this should be an @ The port number should appear somewhere here, but we can skip that because it's 27017, which is the default port number. All right, looks like we are up and ready. And after refreshing the page, you can see we get nothing because we don't have anything configured on the home page route. But you can see the obvious problem here now. Because we are serving this bundle from the server, this route right here is handled by the Node.js process, right? And it cannot find it inside static folders, so nothing really happens. So one more thing which we need to do in the server file itself is do this part, which we actually wrote a pseudocode for. So we can go to the end of file and we can right here just say app.get on every single route which is not matched above. Just go ahead and, as far as I can remember, we just have a request response rest.send file path.join dir name, and we have the build index, not build actually, static index.html, right? And I do believe that we might have to import the path package. I'm not sure if we already have that. Doesn't look like, so we can just say require path, just like this. Some mini changes, but hopefully that will be enough. So let's do it one more time and refresh the page, and let's see if that works. That definitely works, because now what's happening is that on every single route, we are technically just redirecting it to React app. And this React app right here hits this area where it tries to guess that using the browser router. So we have defined it for login, we have defined it for registration, and we have defined it for dashboard. So let's go to register right here and open our debugger, and right here let's try out with a new Mehul name and pass email as mehul@test.com. Paste this, register, and right here you can see the second obvious problem. We have localhost 1337, which is hard coded, which is probably our fault inside the front end. So let me just fix that up really quick and resume the video again. Okay, after making this change on the back end by removing the localhost 1337 hard-coded route, if we just build it and try it again, what we will see is when I hit on register, we get a 200 OK response from the server. That also means our MongoDB connection is working absolutely fine. And all I have to do now is just log in with the same credentials, and I should be able to go to my dashboard and say whatever I want, right? And update this code. This is happening over the intranet on MongoDB as well. All right, so the next step now is to configure PM2 to start this, right? Instead of just running it via node. So all you have to do for that is go to the folder, write PM2 start index.js, and that's it. PM2 will now take care of this Node.js process not going down, or if it's going down, just restarting it. And anytime you want to take a look at what's running, what's not running, you can see PM2 is running right now. It's not using a lot of CPU, and if you go ahead and refresh your application, it is just gonna work pretty much the way it was working locally as well. I'm gonna cover one final part before we close this video, that is how to set up a custom domain and an HTTPS certificate, because I believe a lot of people still struggle with that. So what I'm gonna do is I have this domain called webx.sh and it's running on Cloudflare, but pretty much all you have to do is figure out what your registrar is for the domain and go to the DNS section of that registrar. It could be GoDaddy, it could be unlimited websites out there. You have to arrive at this panel which allows you to add a record somewhere in your domain. And all you have to do in order to map a domain to an IP address is click on this add a record. Make sure this is an A record, because an A record tells the DNS where the domain should resolve to. And in our case, this is this IP address right here. I'm gonna hit an @ for root. For you, it might be just www or anything, but @ is fine. Just put the IP address, nothing else. You can just remove the proxy if you want. It's fine if you just keep it on as well. But the moment you do that, now this domain right here will start pointing to this IP address. So if I visit webx.sh, you can see that it still loads that application. If I go to register, for example, or dashboard, as a matter of fact, you will see that it just resolves to the correct IP address. And again, you would need to log in first. So I had an account mayhole@test.com, I guess. And if I hit login, let's see, we have logged in successfully. And right here, you can see whatever I want is the code which I saved. So the final nail in the coffin is to actually install Let's Encrypt's certbot in order to provide an HTTPS certificate. And for that, you can just pretty much follow this DigitalOcean guide/commands. You don't necessarily have to read all of this, but all you have to do is install something known as certbot. Now the certbot is a package which will help you not only just generate these HTTPS certificates, but also renew them over time. So this also we need to do a small Nginx change as well, which we will take a look at. But let's go ahead and first of all install the certbot properly. You can see once that is installed, certbot is installed, we need to modify the Nginx site available, which we just did. Let's just go into Nginx, etc Nginx again, and take a look at this sites available folder. And inside default, we have to change the server name, the block which we had for server name, I guess. Yeah. So we had this underscore right here. You have to replace it with webx.sh because certbot needs to know which domain it is creating a certificate for, right? And once you do that, that's pretty much it, because certbot just needs to read it. You may reload Nginx, but to be honest, it's not really required. But yeah, you can do that. That's fine. There we go. And then finally, all you have to do, we know that we don't use the UFW firewall on DigitalOcean, so we can skip this. All you have to do is copy this much part, paste it, and then write the name of your domain. In this case, it's webx.sh. You can put email ID if you want, mayhole@codedamn.com. For me, not that it matters. You can just agree. That's fine. That's fine. And you can see now it performs some challenges and verifications. It's going to give you a DNS challenge to prove whether you own the domain or not. You can just select number 2 as redirected to all, and that's it. You have occupied the required certificates. And I forgot to mention, you don't really need a DNS challenge because it's just doing a verification on your path, on placing some files on your domain and then trying to hit them to see if they are present. You need DNS challenge if you want a wildcard subdomain HTTPS certificate. But once you do that, once you complete this, all you have to do is nothing, basically. That's it. That's all that needs to be done. And if you refresh this, you're going to see that you automatically get redirected to the HTTPS version now. So this is how you have deployed a complete application on DigitalOcean with a managed database and droplet compute without actually just killing yourself or spending hours and days on that. Now there is one component which is still left here, which is the continuous integration and continuous deployment using GitHub Actions, which would ease our life so much that all the further updates in this full stack deployment folder are just a git commit away, right? That's all you need to do. But that is going to be part 3 of this, which would be most likely the final part of the series. But I hope you are enjoying this. Hope we would cover some more important practices in the next video, taking a look at how you can set up a CI/CD, how that will help you speed up your workflow, how you can add some tests as well, even if you want, and how you can gracefully reload the application once the deployment happens. So that is all for this video. Hopefully you were able to follow along and complete this full deployment. In the next one, we'll be focusing more on CI/CD, that is setting up a continuous integration and deployment pipeline with GitHub Actions, which is going to simplify a lot of the problems in terms of updating the code and refreshing, reloading the service under the hood as the updates happen. But that's all for this one. If you liked it, make sure you leave a like, subscribe to the channel, and thank you so much for watching. I'm gonna see you in the next video really soon. If you're still watching this video, make sure you comment down in the comment section, I watched this video till the end. Also, if you're not part of CodeDamm's Discord community, you're missing out a lot on events which we organize on a weekly basis to code. You already know the drill. Make sure you like the video, subscribe to the channel if you haven't already, and thank you so much for watching.